Hello everyone. Today I'm going to discuss the second problem of AtCoder regular context 156, which is mix on Blackboard. This problem is quite interesting. So what is the problem? The problem is we are given a finite multiset S of non-negative integers. And we are given the definition of mix S here. I know you know the definition of mix S. So mix is nothing but maximum excludant. So let's say we have a set of some numbers. So mix of this set will be nothing but the minimum non-negative number which is not present in the set. So for this is the mix will be 3 because 3 is the minimum non-negative integers present in the set. So let's take another example. Let's say our set is 1 comma 3. Now 0 is the minimum non-negative integer which is not present in the set. So the mix will be nothing but 0. So I hope you got this explanation. This is already explained in the problem statement. And another thing is that mix of empty set is also 0. So there are negative integers written on a blackboard. The integer is ai. You will perform the following operation exactly k times. So what we can do, we can take any numbers from this blackboard. We can take one number, two numbers, three numbers, uh, any of the subset of the numbers present in the blackboard, and we can write in the blackboard the mix of that subset. So let's take this example. Let's say our blackboard contains number 1 and 3. So we can take this element, only this element, the subset 1. The mix of this subset will be 0, so we can write 0 in the subset. Now let's say we are doing the second operation. Now we can take 1 and 0 as a subset. 1 and 0 as a subset of these three numbers. Now the mix will be 2, so we can write 2 in the blackboard. So we have to find out what will be the how many multisets can be the multiset of the integers on the final blackboard. So the statement is quite, I can say, quite complicated here. So let's take some example. Let's say we are given some set 0 0, and we can do two operations. So in the first operations we can choose some empty set. So we can put either 0 here, so this could be 0 0 0, or we can take this one of the zeros or two zeros, so we can get the mix of the set 1. So we can write 0 here or 1 here. Now in this case we can take another empty set, or we can take only one. The mix of the subset will be 0, so we can add 0 here. So it will be 0 0 1 0, or we can take 0 1 here. If we take 0 1, this mix will be 2. I have already explained why. So the subset will be 0 0 1 2. Now for this again you can take empty set, so it will be nothing but 0 0 0 0, and you can take only 0 or 2 zeros or 3 zeros, so the mix will be 1, so it will be 0 0 0 1. Now this set and this set are same, so total number of possibilities are 1 2. This one is also contributing to 1, so it will be 2 and 3. I hope you got it. There might be some other case I am missing out currently, but I hope you got what I am trying to explain here. Now let's jump back into the problem. So we have to find the multisets. So here the answer might be 3, I'm not sure completely. And we have to find the total number of multisets modulo this integer. Okay, now let's go into some observations. The first observation I have already explained you, that you can do this kind of thing here. Now let's jump into some other observations. So the second observation what I have made is that let's say we want to add 0 in the set. If we want to add 0 in the set, what will be the number of operations we need previously? We don't need any operations, we can directly add 0 here. So minimum number of operations to add 0, let's call it as op. So we will define an array op which will contain minimum number of operations needed previously to add this element into the array. So if we want to add 0 in this array, let's take this example, let's delete this. So if we are only thinking about this example 1 3, and we want to add 0 in the array, we only need one operation. So let's forget about that one operation, but we are not needing any other operation previously adding some other elements also. You will got to know what I am trying to say. So for adding 0 we are not needing any operation, so let's say 0. Now for adding 1, 1 is already present, so we don't need any other operations to add 1 in this array. Okay, now for adding 2, we previously have to add 0, so one operation is needed, because What op means? Op means the minimum number of previous elements we need to add into the array to add this element. So for adding 2 we need to add 0 in this array, so for this will be 1. Okay, so for 2 0 should be added. Now for 3 3 is already added here, but here you can say 0 for having makes as 3 we need to add 0 and 2. We need to add 0 and 2 in this array to have makes equals to 3. So now the operation will be 2, because here you can say this is 0 should be added and 2 should be added. I hope you got it. Let's delete this and write some here. So let's say this is 0. So for 4 this is also sorry. So for 4 we only need to add 0 and 2, so then this is also 2. So for 5 we have to add 0, 2 and 4, so this will be 3. So I hope you can build this array by yourself by some pen and paper or in whiteboard. So this is the array we have built. The minimum number of operation, minimum number of previous elements we need to add to have this element. Now we have a blackboard. Okay, we have a blackboard of some elements, let's say 0, 1, 2, 3. Now let's say we have performed these operations. You can say this op array is strictly increasing. It's not strictly increasing but increasing, because let's say we have added 4, then for adding 5 we have to add all the elements for adding 4. So you can say this array is increasing. So if we have added 5 here, so that means that 4 is already present in the blackboard. So let's say 5 is already present in the blackboard, then all the previous elements are present in the blackboard. Now if we want to add 5, we only need one operation to add 5, because we can take only this 5 elements and the makes will be 5, so we can add another 5. Okay, I hope you got it what I am trying to say. So uh, let's take a break. So what I am trying to explain you, let's say we want to add 5 in the blackboard, then we have to add 4 in the blackboard first. That's what I am trying to say. I might be complicating it, but that's what I am trying to say, is that if we want to add some number, let's say n into the blackboard, then we have to add some number m, which is all the numbers which is less than n in the blackboard first. That's what I am trying to say, and that's what op denotes. Okay, so let's say let's jump into the code. I will explain the code first. I think that will clear all your doubts. So here we are building the op array. Okay, the op array means let's say this part is quite tricky, because this is finding makes, and we are finding that if our makes is, let's say, 4, what are the number of elements we are adding. So first the visited array will contain all the elements of a. Now when we are adding some other element in the a, we are just incrementing the count and marking it as visited. Okay, that's how we are calculating the array, and when we are incrementing the makes value, we are finding op of makes equals to the count, the number of elements we have added. Now this part is quite tricky and quite interesting also. This part requires some knowledge about permutations and combinations, so let me explain that part to you first and then we will jump into it. Now let's say we have all the elements up to xn. Okay, we have all the elements up to xn, from x1 to xn. Now in the blackboard we can add all the elements from x1 to xn. Let's say we have k operations. Okay, so we don't need any previous operation to add this element. So what we can say, the count of first element, let's say c1, so the count of second element, let's say c2, the count of third element, let's say c3, plus dot dot dot, plus cn should be k. Okay, because we don't need any other operations to add this element in the blackboard. Okay, so let's take some example that make these things clear. So let's say in the blackboard we have 1, 2, 3 and 0. Now we can easily add 0 in the array. We can take any empty subset, or we can take only one, or any subset of containing other 3 elements. So we can add 0 with only one operations. So we can add 0. Similarly, we can only take this 0 and we can add 1, or we can take these 2 elements and add 2, or we can take these 3 elements and add 3. Okay, so what things you are observing is that we can add this element easily, like only using one operations. Now let's say we have k number of operations, so we can add this 0 k times, or this 1 k times, this 2 k times, and this 3 k times. So what we can say, let's say we have added this 0 c1 number of times, this one c2 number of times, similarly this 3 at cn number of times, let's say. Now we can say this is the equation c1 plus c2 plus c3 plus dot dot equals to k. Now this is a quite a famous trick named as star and bar trick. You can find it in CP algorithm. I am not explaining this algorithm, but this requires some multinomial theorem things. So the formula here is nothing but n plus k minus 1 ck. So total number of possibilities of selecting c1, c2, c3, cn is nothing but n plus k minus 1 ck. Okay, so this is the formula we are requiring here. You can search star and bar. Okay, search star and bar trick, permutation and combination. Okay, so I have explained this. Now let's jump into the code again. Now while we are iterating over I, we want to add I in the Blackboard. Okay, so we want to add I in the Blackboard. So let's say we want to add c3. Okay, we want to add c3. Now c1 plus c2 plus c3 equals to k. Now as I already explained that to add c3 in the Blackboard, we must require of 3 number of elements to add previously. So we can say c1 plus c2 plus c3 plus of 3 equals to k, or we can say c1 plus c2 plus c3 is equals to k minus of 3. Now another interesting thing to observe here is that we are saying that we are adding c3 here. Okay, 3 here, we are adding 3 in the Blackboard, but this formula also has a case where c3 is 0. Okay, also as a case c3 is equals to 0. Now when you solve this kind of problem, you can take, let's say, if you want to say cn greater than equals to an, you have to delete this an from k. So we can say here an a3 is 1, because c3 is greater than equals to 1, so we can delete minus 1 from here. So c1 plus c2 plus c3 equals to k minus of 3 minus 1. Now again this formula will be applied here, so you can apply this formula. So let's jump into the code. So remaining is k minus 1 minus of I. So if rem less than 0, because if k less than 0, this thing is less than 0, there is no need, because we can't do this operation, this formula will be invalid. So we are just doing continue here, or you can do break, because this thing is increasing, I have already told you. And again this is nothing but answer plus ncr plus I plus rem comma rem, because we are not so this thing I plus rem minus 1 c rem. Let me think why I have done this. Let me think, because this will be n plus k minus 1. So this should be this rem plus n minus 1 c rem. This should be the formula, but why this is rem plus? Oh, I hope I got it, because we are doing zero based indexing here, and this let me delete this part. Okay. Okay, now we are iterating over this I. Here we will have c1 plus c2 up to I, ci plus ci will be equals to k. Now as we are using zero based indexing, so our formula will be nothing but rem plus I plus 1 minus 1 c rem. Because we are using zero based indexing, this 1 and 1 will get cancelled out, this will be rem plus I c rem. So that's what we are doing, and at the end we are printing answer. This problem is quite interesting, but if you don't know about stars and bars trick, you need to go through the CP algorithm blog or any other YouTube video to find out how this algorithm works. And after that you can go through these equations and how am I doing it, how we are building this operation array. What is operation array? Let me try to say again. Operation array of operation of I is nothing but to find to add I in the Blackboard, how many previous elements we need to add in the Blackboard first. So that's why op is also increasing. I have already told you. If you have any doubt in any part of the video, any explanation or in the code, you can write in the comment section. I will try to reply each and every comment. I will also provide the link of the CP algorithm blog in the description box. Please like the video and please subscribe to the channel. Thank you.